This video is produced by Sammy and
Kevin Burgess
for by Inquisition Press to support the workbook Sophomore Organic Chemistry 2 by Inquisition, available from www.byinquisition.org.
Acylation reactions of acid chlorides and anhydrides. This is very empowering stuff because these reactions enable you to couple fragments together to form things like aspartame, the sweetener. Once again, the mechanism is different under acidic and basic conditions, and you know that you protonate under acidic conditions, you don't under basic conditions. If we take an acyl chloride and add a carboxylate to it, what do we get, Sammy?
An anhydride.
An anhydride. Very good. You can make symmetrical anhydrides from acid chlorides and carboxylates. So for instance, we could take pentanoyl chloride and benzoic acid and couple them together, or two different aliphatic carboxylates to make unsymmetrical anhydrides via this method. If you look at an unsymmetrical anhydride, there are two ways of making it. If it's symmetrical, there's only one. Propionic anhydride can only be made by this method from propionyl chloride and the carboxylate of propionic acid. But for this anhydride that has a 2 and a 3 carbon acyl fragment joined together, could you tell me one component I could use? One acid chloride?
Ethanoyl chloride.
And this would be the carboxylic acid from propionic acid. Or you could use which chloride?
Propionic chloride?
Propionyl chloride, yes. And acetate. In the next one here, this is unsymmetrical too. We could use your friend benzoyl chloride and the carboxylate of propionic acid. Or what else could I use?
Propanoyl chloride.
Propanoyl chloride, yeah. And
benzoate.
Yes. One of the easiest things to acylate for an acid chloride is water. If you add water to an acid chloride, the reaction goes very quickly. You add water to an acid chloride, you get a tetrahedral intermediate, then loss of a proton, and subsequent loss of chloride will give the acid. After deprotonation, you get a carboxylate. Similarly, if I take an alcohol and I add it to an acid chloride, then the net reaction is formation of an ester with loss of HCl. And I can do that for a variety of esters like butanoyl chloride and benzyl alcohol, benzoyl chloride, and 2-propanol. Thinking backwards then, whenever we see an ester, it could be made from the corresponding acid chloride and an alcohol. If it's cyclic, that has to be an intramolecular reaction. But if it's acyclic, that will be ethanoyl chloride and ethanol to give you ethyl acetate, or allyl alcohol and benzoyl chloride to give you this ester, and so on. One of the most empowering reactions is acylation of amines. Again, we just form a tetrahedral intermediate, proton transfer, and loss of chloride will give us an amide from a primary or a secondary amine. It's very reliable. Would I get any product from trimethylamine and benzoyl chloride?
No.
Because there's no hydrogen to be lost. So it has to be secondary or primary or ammonia. We can form primary amides from ammonia, secondary amides from primary amines, or tertiary amides from secondary amines. Pyrrolidine will give a bis amide in this example. And then again, thinking backwards, we can form N,N-dimethyl ethanoamide from ethanoyl chloride and dimethylamine. We can form this one from hexanoyl chloride and piperidine.
If you have an acid chloride of one amino acid and an ester of another amino acid, can you put them together to create a dipeptide?
Yes, good question. You can. And that is a way of forming peptides in general in solution. Acylation of carboxylic acid anhydrides is similar to acylation of carboxylic acid chlorides, except that the leaving group is a carboxylate. If the anhydride is cyclic, the carboxylate is trapped in the same molecule, and if the carboxylate is acyclic, you transfer one acyl group from a symmetrical anhydride. Isotoic anhydride is a nice one because we transfer the acyl group to the nitrogen and lose CO2 and eventually get an anthraquinonic acid derivative. And most important are acylation reactions of amino acids. Protected amino acids will react with anhydrides to give amide bonds and extend the peptide chain.